Hi, Algebra 2 students. We're going to start a new chapter this week about rational expressions, and we'll be doing lots of reviewing about things that you've learned in the past and applying them to these expressions. So why learn this? Representing change and equivalence in a variety of forms has helped humans apply their understanding of scientific principles. So as we're learning this, you're going to notice we're kind of away from a lot of word problems because these are skills that you need in calculus in order to solve those higher level word problems. And so when you're sitting here wondering about why am I learning this? This has huge applications, but it's applications in higher level math. Again, the engineers who build the bridges you drive on, do you want them to understand calculus? I do. All right. So let's just do some vocabulary to get started. First, what is a rational expression? A quotient of two polynomials. So think about a rational number as a fraction. This is going to be a fraction of polynomials. How do I simplify these? First thing you do is you factor the numerator, factor the denominator, cancel the things that they have in common or that form quotients of 1, and then you multiply what's left over back together. When is a rational expression undefined? And that answer is when the denominator is equal to 0. Just like any other fraction, we can't divide by 0. So using these rules and these ideas, let's start by just simplifying some rational expressions. It says simplify, then we'll identify any x values for which the expression is undefined. Okay, well right now I see a monomial in my numerator and one in my denominator. So first thing I'm going to do is just look at the numbers and reduce that fraction just like I've known how to do since elementary school. The common factor they have is 2, so that can reduce to 5 over 3. Now I look at my x's. This is a review from earlier in the year with our exponent rules. Remember, 2 powers with the same base. If they're being divided, we can subtract their exponents. So that leaves me with 8 minus 4, 4 in my numerator. So there it is. Next thing we need to do is identify any x values for which the expression is undefined. And when we do this, we need to do this with our original function. So I'm going to come back to the original and I'm going to ask myself, what value will make this denominator of 6x to the 4th equal to 0? And if I solve that equation, I know 0 times anything is 0, so I'm going to write here, x cannot equal 0. I've got 2 more of these for us to try together. Now we see a quadratic trinomial, so we get to review how to factor those. So we'll break down this first one. Remember, we ask ourselves what multiplies to -2 and adds to 1. So what multiplies to -2 and adds to 1, and we'll have a positive number and a negative number, be +2, -1. So that's what my numerator factors to, x plus 2, x minus 1. Now I'll factor my next one, what multiplies to -3 and adds to 2. Again, we have a positive number and a negative number. And so that would be 3 minus 1. All right, now you can probably notice right away that we have 2 terms that are the same. And so remember, when you have 5 divided by 5, it's 1. X divided by x is 1. X minus 1 over x minus 1 is 1, so this cancels. So we multiply together what's left because sometimes we'll have more than one thing left in our numerator or denominator. But in this case, all I have left on top is x plus 2, and all I have left on bottom is x plus 3. So this is what it simplifies to. Now I have to go back though and answer the second part of the question is where is it undefined? And when I answer that question, remember I have to look at my original function, but it's easier for me to solve for 0 in a factored form. So I am going to look at my original function in its factored form, and I'll see that there's 2 values for which x is undefined. So x cannot equal -3, because -3 plus 3 would be 0, and it can't be +1. All right, last one of these. Again, we are going to simplify and then identify for what values it's undefined. So I'm looking at my numerator, and this is not a quadratic trinomial. It is not a difference of squares, but I do see a common factor. I see that I can factor out an x, so I'm going to start with that. So I'm going to factor out the x, and then I'll have a 4 minus x. Let's go to our denominator and factor that. We say what multiplies to -8 and adds to -2. So it'll be a negative number and a positive number. The negative one will be bigger, -4 plus 2. So x minus 4, x plus 2. Now, I can see that these 2 right here are very close to being able to cancel, but they're opposites, okay? So what I can do is I can factor out a -1. So if I go up here and I factor out a -1 from my numerator, and then I have my x, and then if I divide these by -1, now I'll have a positive x and a -4. And now I can cancel because I've got the positive x and the -4. All right, so this cancels and this cancels. And what I'm left with is a -1x. I'm just going to write -x over x plus 2. So the thing that makes this example different is we had to factor out a -1 in order to be able to cancel. And it is okay to do that. Now let's head back over to our original form here, or our original expression in factored form, and find what x cannot equal. Remember, it's whatever makes the denominator 0. And what would make this denominator 0 is if x were 4 or if x were -2. Okay, so we have 4 skills we're going to learn this week. We'll do the first 2 in the first video, the second 2 in the second one. The next skill is multiplying rational expressions. And we're going to multiply them the same way we multiply fractions. But to make it simpler so we don't have such complex polynomials we're working with, we're going to factor and cancel what we can, and then we'll multiply across the numerators and multiply across the denominators, okay? So our first one just has monomials in the numerators and denominators. And sometimes when you have monomials, it gets actually a little bit more tricky. So we're just going to do the best we can, and then we might have to go through a second phase if this gets too messy. So we're going to be looking up and down, as well as diagonally. We're going to be looking for any common factors, things that we can cancel. So for example, I see that I can cancel a 3, and I can change this 9 to a 3, because if I divide them both by 3, if I factor out a 3, I've got 1 and 3. Same thing over here, 2 and 10, that's 2 divided by 2 is 1, 10 divided by 2 is 5. Let's see what else we have. Ooh, I have an x cubed here and an x cubed there, so those cancel. And then it looks like a lot of other x's and y's I can subtract. So I'm going to take a pause here, rewrite what I've got, and then keep simplifying. But when I rewrite it, I'm going to take note in the fraction here. I've got a y cubed and a y7. Remember, I can subtract those exponents. So I've got an x to the 5th at the top. There are more y's on bottom, so I'm going to say 7 minus 3 is 4. So there's 4 y's left on bottom. The next numerator, it looks like I'll be able to simplify some y's again, but I've got the 5 on top, the 3 on the bottom, the x squared on the bottom. There are more y's on bottom, so I'm going to write them down there. And 5 minus 4 is 1. Okay, let's look at what other canceling we can do, and then we'll be ready to write this one out. Here, x to the 5th and an x squared. 5 minus 2, so there won't be any left here, but I would have an x cubed here. And when we multiply these y's together, we'll add their exponents for y to the 5th. So we're ready to write out our answer. X cubed, oops, I should put the 5 in the front. 5x cubed over 3, and then we'll have y to the 5th. Now I could have done this all in one step, but notice this was getting messy and hard to read over here on the left. That's why I took a break. I also could have canceled things differently and in different orders. Okay, I could have even multiplied straight across and just said 30 x to the 8th, y to the 7th, and then multiply the bottom straight across, and then do all my canceling. So when we work through these problems, there is one correct solution, but there are multiple paths to get there. Okay, so if the path that you saw right away was different than mine, that's just fine. Okay. All right, last thing. The directions for these say assume that all expressions are defined. That means we don't have to worry about looking what x can't equal. Okay, we get to skip that part. All right, let's try another one. Remember, we're going to factor, cancel what we can, and then multiply things together. X minus 3 is not factorable, but the denominator has a greatest common factor of 4. So I'm going to factor a 4 out of the x plus 20, and I'll have an x plus 5. The next numerator cannot be factored, but the bottom one is a difference of 2 squares. That factors to x plus 3 times x minus 3. And now hopefully you're seeing things up, down, or up, down, or diagonally that can cancel. Like this x plus 5 cancels with that one. This x minus 3 cancels with that one. So now I'm going to rewrite what I have left on top. So that's my factor, my cancel. Now I'm doing the remultiply. There's nothing left on top. There's a 1 left on top. Remember, when we're canceling, we're finding quotients of 1. X divided by x is 1. There is a 1 left on top. There's never nothing left when we're multiplying and dividing. And on the bottom, I have this 4 and the x plus 3. You can choose to leave your answer in this form. You may also choose to write your answer as 1 over 4x plus 12. Both of them are 100% correct. So I'm going to circle both. All right, so that's it for this video. We have looked at some definitions, we have simplified, and we have multiplied. In the next video, we will divide and solve. I'll see you in a few minutes.